All right, so in this video, we are going to solve the following differential equation. So how do you suppose we solve this differential equation? Well, notice it's a higher order differential equation in which we have constant coefficients and it's homogeneous. So in order to solve this, what we could do is we could transform this into a polynomial equation. Right? Where basically our derivative number will become the power. And so basically we're just going to solve for r. And to solve for r, we can factor out r squared. And it turns out in this parentheses we get a quadratic. And it turns out we can actually factor this quadratic. Right? So now we have factored it, and now we can use the zero product property. Right? And so now we're going to solve for r in each of these. For the first one, we basically would take the square root of both sides, and we would get that r is equal to 0. For this one, we get that r equals -2. For this one, r is equal to 1/4. And so we basically solved for r. And we're going to use these values of r to write the general solution to this differential equation. But it's important that you identify the types of roots that you have. For the first root, notice that this is actually a repeated root because when you take the square root of both sides, you technically get plus or minus 0. So this would be considered a repeated root. And these two roots can be considered two distinct real roots. And I'm going to give each of my roots names. Right, and now we're ready to write out the general solution to this differential equation. Right, so the way it works is we need to take into account each of the types of cases we have. For our repeated root, if you recall, the way it works is we would write it like this. Right, that's what we would do for our repeated root. And whenever we have distinct real roots, in this case we have 2 of them, we would do this. Right? Just like that. Basically, we add all this together. That tells us our general solution. And so now all we're going to do is we're going to substitute r1, r2, and r3, that is our roots, into our general solution. Right, so this is what we have, and we know that e to the 0 is just 1. So that simplifies this too. And so this is our final answer. As you can see, that's how we could solve a differential equation in which we have higher order and constant coefficient homogeneous. And so this is an example of which we had that. And so this is basically it for this video.